Welcome to another journey with Mathematics A. Content standards. The learner demonstrates understanding of the key concepts of inequalities in a triangle and parallel and perpendicular lines. Performance standards. The learner is able to communicate mathematical thinking with coherence and clarity in formulating, investigating, analyzing, and solving real-life problems involving triangle inequalities and parallelism and perpendicularity of lines using appropriate and accurate representations. Today's learning competency shows the theorems on triangle inequalities. Our topic, theorems on triangle inequalities. Are you now ready? Let's recall. When can we say that two triangles are congruent? Well, two triangles are congruent if their vertices can be paired so that corresponding sides are congruent and corresponding angles are congruent. The purpose for this lesson is that you are going to show the theorems on triangle inequalities. Be ready, for we are now about to start the lesson. Let's talk about inequality. What are the inequality symbols? The inequality symbols are the greater than and the less than, as well as the greater than or equal to and the less than or equal to. Let us say we have triangle XYZ. Now, what are the angles of the triangle? Can you name it? Of course, the angles are angle X, angle Y, and angle Z. How about, what are the sides of the triangle? Can you name it again? Well, the sides of the triangle are XY, YZ, and ZX. Let's discuss further regarding the parts of a triangle. Let us say we have triangle XYZ and you are going to arrange the angles from smallest to largest according to the tick marks. On the illustration, angle Z has one tick mark, angle X have two tick marks, and angle Y have three tick marks. Therefore, if we are going to arrange, angle Z should come first, followed by angle X. Last would be angle Y. This time, let us discuss the different theorems on triangle inequality. The theorems on triangle inequalities. Triangle inequality theorem number 1, that is sides to the angles. Triangle inequality theorem number 2, that is angles to the side. Triangle inequality theorem number 3. Side 1 plus side 2 is greater than side 3. Lastly, exterior angle inequality theorem. Triangle inequality theorem number 1, which says, if one side of a triangle is longer than the second side, then the angle opposite the first side is larger than the angle opposite the second side. Let's apply triangle inequality theorem number 1. Let us say we have triangle XYZ with the following tick marks. Now, what is the longer side? Side YZ. Correct. What is the shorter side? Side XY, and that is correct. Our conclusion would be, since YZ is longer than XY, therefore, the angle opposite to YZ, which is angle X, is larger than the angle opposite XY, which is angle Z. In symbols, that is, angle X is larger than angle Z. Triangle inequality theorem number 2, which says, if one angle of a triangle is larger than the second angle, then the side opposite the first angle is longer than the side opposite the second angle. Let's apply triangle inequality theorem number 2. Let us say we have triangle ABC with the following tick marks. Now, what is the larger angle? Angle A, and that is correct. What is the smaller angle? It's angle C. Therefore, let us now conclude. Since angle A is larger than angle C, therefore, side BC is longer than side AB, since BC is the opposite of angle A. In symbols, that is, side BC is greater than side AB. Let's talk about triangle inequality theorem number 3, which says the sum of the lengths of any two sides of a triangle is greater than the length of the third side. Example, let us say we have triangle ABC. Let side AB be the side 1, which measures 3. Let side BC be the side 2, which measures 4. And let AC be the side 3, which measures 5. Applying the concepts, we can say that BC plus CA is greater than AB. Substituting the values, we have 4 plus 5 is greater than 3. Summing it up, we can say that 9 is greater than 3, which is correct. Another, we also have AB plus BC is greater than CA. Substituting again the values, we have 3 plus 4 is greater than 5. Simplifying, we have 7 is greater than 5, which is also correct. Lastly, we have CA plus AB is greater than BC. Substituting the values, we have 5 plus 3 is greater than 4. Simplifying, we have 8 is greater than 4. Lastly, we have exterior angle inequality theorem, which says the measure of an exterior angle of a triangle is greater than the measure of either remote interior angle. Let's take a look with the illustration. Angle 1 and 2 are the remote interior angles. They are the two interior angles that do not touch the exterior angle. Let us say the measure of angle 1 is equal to 40 degrees and the measure of angle 2 is equal to 80 degrees. Note that the sum of the measures of the interior angles of a triangle is 180 degrees, and the sum of the measures of the angles in a linear pair is 180 degrees. Therefore, what is the measure of angle 3? The measure of angle 3 is 60 degrees. How about the measure of angle 4? You got it right! Angle 4 is 120 degrees. Let's discuss further. In the given, angle 1, which measures 40 degrees, is a remote interior angle. At the same time, angle 2, which measures 80 degrees, is also a remote interior angle. Whereas angle 3, which measures 60 degrees, is an adjacent interior angle. Finally, angle 4, which measures 120 degrees, is the exterior angle. Applying the concepts, we can say that the measure of angle 4 is greater than the measure of angle 1. Note that angle 4 is an exterior angle, and angle 1 is a remote interior angle. Substituting, we have 120 degrees is greater than 40 degrees, which is correct. Since angle 2 is also a remote interior angle, we can also conclude that the measure of angle 4 is greater than the measure of angle 2. Note that 120 degrees is greater than 80 degrees. Let's sum it up. We had just discussed the theorems on triangle inequalities. Triangle inequality theorem number 1, or that is the relationship between the sides and the angles of a triangle. Triangle inequality theorem number 2, or that is the relationship between the angles and sides of a triangle. Triangle inequality theorem number 3, or that is the sum of the two sides of a triangle is greater than the third side. Finally, exterior angle inequality theorem. Let's think about our topic. How can we relate the concepts of theorems on triangle inequalities in our daily living? Can you now discuss the concepts of theorems on triangle inequalities? I guess you are now ready, and you can now do it. Here is your task number 1. Let's take a look at this. We have the illustration with the following given. The measure of AM is equal to 5 cm. The measure of side MT is 6 cm. And the measure of side TA is 4 cm. Your task is to answer the given question. Using the above data, what would be the correct inequality symbol in the following mathematical statements? Let's proceed with your task number 2. Let's take a look again with the illustration with the following given. Angle 2 is equal to 62 degrees. Angle T is equal to 54 degrees. And angle A is equal to 64 degrees. Question to be answered. Using the above data, what would be the correct inequality symbol in the following mathematical statements? It is now time to check your answers. Here are the answers for task number 1. For task number 2, we have the following answers. Let us now evaluate what you have learned. Given, first we have the illustration. Next, let the measure of angle 1 is equal to 60 degrees. The measure of angle 2 is equal to y. The measure of angle 3 is equal to x. And the measure of angle 4 is equal to 140 degrees. Your task: show the relationship between angles and sides of a triangle using the concepts of triangle inequality, then compare the measures of the angles using inequality symbols. Are you now excited to check your answers? Your task, and here are the answers. After checking your answers, how's your score? Well, that ends our lesson for the topic Theorems on Triangle Inequalities. And I would like to say thank you for viewing this video. Our heart is full of gratitude to the Almighty Father for the gift of persons who in one way or another had helped us in realizing this video. Special thanks to the following: Odobias D. Elentorio, EPS for Mathematics of the Cotabato Division; Nelia A. Versola, Ed.D., Municipal Cluster Head, Municipality of Mlang; Nelly L. Omisol, MT1, Municipal Math Coordinator. Together with the following principals: Sammy G. Dislate, Principal 1; Rolando E. Buenaflor Jr., Principal 1; Janeline A. Domingo, Principal 1. To the Master Teachers of the Municipality of Mlang: Susan A. Peroy, MT1; Lynette D. Alunsagay, MT1; Rafael P. Alintahan, MT1; Rafcora J. Pacolor, MT1; Mary Melanie A. Tison, MT1; and Betty G. Cabangon, Head Teacher 3. This is Joan May Gocking Andea, Mathematics 8 teacher of Nueva Vida National High School, Nueva Vida, Mlang, Cotabato, saying thank you for viewing this video.